Okay, first you add your fractions together, but you have to give them a common denominator. So you have -4/3. And their common denominator is 24, so you times this one by 3 and this one by 8, so the denominator is 24. Then you get 9 over 24 plus -32 over 24. That equals -23 over 24. And then you take your x, the -23 over 24, and you morph it to 1, or not morph, but to x 23 over 24. And then you have to have a fancy one, you times it by, so you have x, 1 to 23 over 24 times x to the 1/24 over x to the 1/24, and it equals x to the 1/24 over x.
Okay, so you start out and you notice that you have a fraction exponent on the bottom, so you just wait, scratch that. I didn't even say that. So you have p over 3 to the thirds. This is really just p to the first, yeah. Then over p to 1/3. Then you just subtract these guys, and you end up with p to 2/3. Bam. Oak City rocks.
Okay, so we take the a to the third and times it by 6 to the 5th, and then you get a 12 to the 15th, and then you times that by a 6 to the 5th, and then you simplify that into 4 to the 5th, so you divide it by 3, 4 to the 5th, and then times that by 6/5. Well, you add it. No, yeah, add it. A 10 to the 5th into a squared.
Okay. So flip them. It's going to be x to the 1/3 over x to the 1/2. And where am I at? Times them by a cool number 1. X to the 1/2 over x to the 1/2. And you get x to the 5/6. So you gotta times by 3 to get the common denominator, and these will make 1, and you're done.
Okay, you break this down, and it's, well, okay, and then come back up here. 5 is your index. How many 2's do you have? And you have 5 2's. Oh. And you have 2 3's. And you can take 1 2 out, and you have to leave the other, or the 3's in, and then you simplify.
So, to start out, Can't remember what I did. Oh, okay. I just converted them into not radicals. So that's 5 to the second, and that one's 5 to the third. So then it's, when you convert it over, then it turns it to 5 2 over 3 times 5, 3 over 2. And then you make a common denominator, so it goes 5, 6 over... Is that what I did? 6 over 4 times 5 to 9 over 6. And then you just add them, and it's 5 to 13 over 6. And then when you convert it back into a radical, then it's the 6th root of 5 to the 13th. And so you have two groups of 6 you can take out, so it comes out to 5 squared on the outside of 5, it's the 6th root, and that's just 25 to the 6th root of 5. Okay, I give up. I'm done.
Okay, so your first step is to take the inside cubed root of 48 and change it to morph it, and that gives you 48 1/3. Then you put that in parentheses and you morph the second one, which gives you a 1/2 exponent. The next thing you do is you times the exponents, and that gives you 48 to 1/6, and then you can morph that to 48, or the 6th root of 48.
Shout out to Maddie, she's great. Okay, ow. Okay, you simplify these in the square root, and so now you have -4 on the square root of, wait, okay, you want to do that again? Okay, you have 2 squared 5 and x to the 3 times, this doesn't go anymore because it's 2, so 10 x to the 3, and then you want to take these out, and so you can take out a 2, so you have -8, and you can also take out an x, so you have -8x on the square root of 5x times, and you can take out an x, so you take out 1x on the square root of 10 to the x, and then you times those, and you have -8x squared on the square root of 50 x squared, and then you want to simplify, wait, yeah, okay, simplify 2 to the 5th, 2 5, anyway, and then you have and you have 2 5s, so you can take out the 2 5s, and you times that with to 8, so you have -40x, and you can take out another x, so you have x cubed, and then you put it over 2 because there's only 1 2 left. Yep.
Okay, so how you solve this problem is you do distributive property. So you would distribute this number and then this number, and you would get 4 1, and you would 4 times 1, and that equals 4, and you would get 4 times 4 to the square root, and then you would get 2 times 1 and this 2 times 4 to the square root, and you would get 4 plus 16 over 2 plus 2 plus 8, and you would get 17 over 2 plus 8 plus 4, and you would that would equal 1 over 2 plus plus 12, and that's your answer. Is that right?
Okay, first you have to simplify. So because you have 3 u's up here and 4 here, you can take these 3 out and change that just to a u, and then you can cross this v out and make that v squared. So now you have 2 over 4 v squared, and then you can simplify your 4 into 2 times 2, and your v, you have 2 v's, so you can take those out, so you'll have 4v over square root of 5u, and then you have to have a fancy one, so you times it by a 5u over square root of 5u, and you'll get 4v over square root of 5u over square root of 25u squared. Then you can simplify your 25, and then you get 4v on the square root of 5u over 5u.
Count 11. The only way to get rid of this square root on the bottom is if you multiply by the conjugate. The conjugate is going to be 2 times the square root of 3 plus 5 on top and bottom. So now it's just a big distributive property. So let's do the top. Let's multiply everything by 2. So it's going to be 4 times the square root of 3 plus 2 times 5 is 10. Okay, on bottom, 2 times the square root of 3 times 2 times the square root of 3 is going to be 4 times the square root of 9. And then 2 times the square root of 3 times 5 is going to be 10 times the square root of 3. And then a negative 5 times 2 times the square root of 3 is going to be a negative 10 times the square root of 3. And these do zero each other out. Those are going to cancel out. That's 0. But the last, a negative 5 times 5 is a negative 25. So this is sweet because the square root of 9 is a whole number 3. So it's really 4 times 3. So it's really 12 minus 25. So the top, we've got 4 times the square root of 3 plus 10. And on bottom, 12 minus 25, is that a negative 23? So you can either leave it, oh, negative 13. You can either leave it like this, but if there was a multiple choice and this was not A, B, C, or D, but this was a negative 4 times the square root of 3 minus 10 divided by a positive 13, they're the same thing. So on a multiple choice, if you get this, but this is your option, they're the same thing.